All right, so this is lesson 7. We call it the circuit analysis. What is a circuit analysis? Is it involves solving problems relating to the circuit using 3 things that we have learned: Ohm's law, Kirchhoff's law, and equivalent resistance. So when we talked about equivalent resistance, if the question gives you all of the R's, okay, the way that the question is going to be asked is they're going to give you a circuit that looks like this, and they will give you a chart with V, I, and R. If they give you all the resistance, so if you know, like, so all the one with the numbers, if they already gave it to you, you can actually use the equivalent resistance. And just a recall of what the equivalent resistance is, okay, if I have something that's connected in series, the RT is the sum of them. I just add them all up. If I have things that are connected in parallel, I would find the inverse and I would add them all up, right? So remember how I said you add everything to the right and then find the inverse button and divide them, okay? The second law that we have talked about is called the Ohm's law, okay? The Ohm's law is solved if you have 2 out of 3 of the unknown. First of all, the Ohm's law is V equals to I times R. And what they mean by if you have 2 out of 3 is if you take a look at the chart here, for example, if they tell you this is 10 and this is 3, do you see within this line here, I have 2 out of the 3 boxes that are filled. And what you can do is you can use the equation V equals to I times R. Since I know V is equals to I times R, to rearrange the equation for I. The middle one is what I'm missing, which is the I, right? So to find the I would rearrange this equation and go V divided by R to find out what I is. Okay, so for this one, as long as I have 2 boxes out of 3, it could be these 2 boxes and this unknown, or it could be these 2 boxes and this unknown. As long as in the same line, I have 2 of them, I can use the equation. Okay, so I'm just going to quickly write the equation for the last one. Okay, if I'm solving for R, rearrange the equation is V over I. So what I'm suggesting to you is write these equations at the top of your chart. Okay, just so that if you're really good in math and you look at V equals IR, I need R, I know that I'm taking my voltage divided by current, then don't worry about it. But if you think that this would be helpful, I would write the equation right at the top. If I need this column, this is the equation that I'm using so I don't make a mistake, okay? All right, so that's the Ohm's law. The third one is probably the most confusing one we're going to review. It's called the Kirchhoff's law. There are the voltage law and the current law. And when you do the Kirchhoff's law, I want you to do a chart, okay? Every time when you do the Kirchhoff's law, you're going to do it for every single circuit, okay? We're going to have voltage and current. I need you to look for voltage and you would do the loop, okay? And you would take your highlighter. Remember how you would physically draw in the loop and then count. And the equation that you're going to write is V gain equals to V lost. Okay, the gain happens at the battery. Okay, the gain, it happens at the battery. And the loss happens at the load. Okay, and then you're going to use a highlighter and physically draw in the loop like this in your circuit. And then count all the voltages that it goes through. Okay, the second thing that we need from the voltage law is if I find anything that is in parallel to each other, then the voltages are the same. Okay, so if I have 2 things that are parallel, like the second resistor and the third resistors are parallel, I would write V2 equals V3. Then for the current law, we're going to find this thing called the junction. Okay, junction is basically if the current comes in and there is going to be a split. Okay, and the current coming in, I in, is going to equals to the I out. Okay, and then the other thing that I look for in a current as things that are in series. When I know 2 resistor or like a battery and a resistor, when they're connected in series, we say that the current that is going through them are the same. Okay, and then you just keep going in circles and keep looking for things that you could do. But the 3 main things you would always do when you do a circuit analysis is you would write out your Kirchhoff's law, You would use the 2 out of 3, find out anything that are in the same row. If I have 2, I can find the third. You just keep going in loops. Okay, so let's go to the example. Okay, so I already put this at the top here. I'm leaving them here. And I wanted to, first of all, read the question and fill in the numbers as much as I know into the chart. Okay, the question tells you you have a source voltage of 12 volt. Okay, source voltage means the T, right? The source is the T, and the voltage is 12, so meaning VT is 12. Resistance value R1, so R at 1 is 15, so I fill it in the chart in the right place. R2 is 25, R3 is 35, and that's all they give you, and then I have to find all the current, all the voltage, and all the resistance. So the first thing we're going to do is we're going to calculate what is the RT. The reason why I chose this step is if you go back to the rule here, see how step 1 says if all R's are given. And that's what's happening in this question. They gave me all the R's, then that means I can do step 1, which is the RT. So let's solve for the RT. Okay, take a look at the circuit here. Okay, the circuit here has 2 things that are in parallel. Do you see that these 2 are in parallel? But then connected to series in this. Okay, so this is the 2-step question in terms of solving for RT. So I'm going to write that step 1. I'm going to find RT. And to do that, the first thing I would do is I would actually find R2 and 3 together. And we already talked about how to label them. R23 means the total resistance for 2 and 3. Okay, and because they are in parallel, I'm going to use the parallel equation. So 1 over R23, it equals to 1 over R2, which is 25, adding 1 over R3, which is 35. Punch it in your calculator, 1 divided by 25, adding 1 divided by 35. And then take the inverse, right? Remember how we would punch in whatever is on the right-hand side, and we would take the inverse. So first of all, I'm going to write this 0.06857, whatever, super big number. And then I press the inverse. I press equal. That's what R23 equals to. Okay, R23 equals to 14.58. Okay, and that's only between 2 and 3, right? I now need to add it in series with R1. So RT is R1 adding R23 because they're now connected in series. So R1 is 15, adding 14.58. So 29.58 is RT. We fill things in the chart as we go. So when I find one, I put it in the chart at the right place. Can you keep 2 decimal places, please? So I'm going to write it here. For all these circuit questions, I need you to keep 2 decimal places. Okay? All right. So then the next thing is, hopefully it jumps to you that I now have a 2 out of 3 Ohm's law. Because I have the 12, and then I have the 29.5. That means I can use the Ohm's law at the top. I is V divided by R, and solve for what IT is. All right, so take your calculator. I'm going to go 12, the V divided by the 29.58. So I got the answer of 0.41 amps. I mean, you don't have to write the unit. The unit is at the top. Okay? So that's the 2 out of 3 that we were talking about. And you're going to keep revisiting it. Okay? So we've done the equivalent resistance. We've done step 1. We've also done the Ohm's law. We will go back to it. The next thing is now the Kirchhoff's law. So I need you to do this table. Very important to get the full mark. You have to show all your work. Okay? So I'm going to do the table for the Kirchhoff's law. Okay? And I'm going to start off with the T chart. You do this every single time. Okay? V and I, you would say loop, parallel, junction, and series. This is how you start every single time. I would even do the headings just so that I know I'm not missing anything. Okay, I'm going to erase these marks on this here. And I'm going to start with a loop. in a loop, I would do a highlighter and actually trace the loop. It always starts off with the negative, so it's going to go this way. And you're going to come on around and you're going to choose up or down. I'm just going to go up. It doesn't matter which one you choose because you will take care of the other one where you do the parallel one. Okay, so voltage gain is VT because I go through the battery. That's VT equals to voltage loss are the load. The two loads that I go through is R2 and R1. So V2 plus V1. Notice if like I'm doing voltage, right? That's why I write this here. So it makes it easier for you to see. Okay, I know it's V. Okay, so the next thing that I do is I'm going to start finding things that are in parallel. So I'm just going to erase this a little bit better. Okay, now that I've done my loop, I'm just going to redo my loop just so we have, you know which one I use. So the loop is the one at the top. Okay, parallels are between the 2 and the 3. Okay, when things are in parallel, their voltages are the same. So meaning voltage 2 have to equals to voltage 3. Now junction. I have to find a junction. Junction is the point that we're splitting. So when the currents are coming in like this, it has to split right here. This is my junction. So I'm just going to use the purple dot to represent that's where the junction is. Okay, at the junction, the electron comes in and it came and it split into two. So I have one thing that's going in equals to two things that came out from it. So what's the name of the current that's going in? It doesn't anywhere close to the purple dot. You kind of have to trace backward. Use your finger and trace backward until you hit the first thing, which is the T. Okay, so current IT is the name of the current that's going in. And it's going to split into two currents. The name of this current that's going through the second one is called I2. The name of the current that's coming out through the I is I3. So I have I2 plus I3. Things that are in series. Series mean they're along one path. And the only things that are in series are these two. Okay, these two are connected in the same line here. Okay, so that's why the current, I'm still dealing with the current. The chart will be helpful for you to recognize it. So the currents that are in series is I1 equals IT. Now that you have all your equations, let's inventory what we have, and then we can try to solve for it. Okay, so I always like to use like another color and check mark off what I have. I'm going to use pink. And I know I have VT, so I'm going to check off VT. I know I have also IT. Okay, that's all I have right now. And you always look for opportunity to solve an equation. What that means is you have to find the equation that only has one thing that you don't know. Okay, do you see this equation here? If I1 equals IT and I know IT, that means I1 has to be the same. Right? So I'm going to go in to the chart. If it's like a single variable like that, you don't even need to show your work. If I know I1 is equals to IT, then that means these two have to be the same, right? So that means that also has to be 0.1. And when I know that, I'm going to start checking things off a bit more. I know I1, I also know I1. Okay? And then the next thing is check for 2 out of 3. Do you recognize that I now, for 1, I have VIR. I know this. Do you see that? I have my 2 out of 3 because this is my 3. I have the 2, right? So that means I'm going to use the equation V equals to I times R. I would go V is 0.41 times 15. So I'm dealing with this one right now, okay? So V is I 0.41 times 15. This equals to 6.15. Okay, when I get something, I check it off. Okay, so I now have V1. Let's see what I can do. I have V1. Okay, do you see this equation? I now can solve for V2 because I only have one thing that I do not know, right? So I'm going to move it to the side here just so that I can do the math here. So I'm just going to do it over here. So I know VT is V2. Adding V1, VT is 12. V2 I don't know. V1 is 6.15. So V2 is going to be 12 minus 6.15. Are we okay with what I did that? So I moved this over to the other side. If you don't like to write it like that, what I can do is I can just say 12 minus 6.15 is equals to V2. All right, some people don't like me rearranging like that, so I'll just, oops, so this is 5.85 volts, okay? When I get something, I filled it in. This is V2, so V2 is 5.85. I know V2, that means I also know V3, right? Because they're the same. So this is also 5.85. Okay, left with the 2 out of 3 ohms law. So 5.85. So to get I have to go V divided by R. So 5.85 divided by 25 gives me 0.23. And then finally the third one, I have to use Ohm's law again. I is V divided by R. So 5.85 divided by 35, 0.17. Okay, so I've done everything. Let's see how the mark goes. Okay, all right. This question will be out of 8. They're a big question. Okay, and you get 1 mark for finding the equivalent resistance. You get 1 mark for each of these equations. Okay, so make sure you do your Kirchhoff law chart. Okay, because if you don't, you're gonna lose mark. Even if the whole chart is filled out, I'm not gonna give you 8 out of 8. Right? Just like always, if you tell me what the answer is, you don't get the full mark. Okay, so at this point, you already gained 5 marks without doing all the complicated, puzzle pieces calculation thing. Okay, and then you get 3 more marks for all the answers in the chart, and that's out of 8. So make sure this is an important chart. Very, very, very important chart that people sometimes forget. All right, let's do the next one. Fill out the information at the bottom. V2 is 12. So I'm just going to use black color. These are the given. Okay, so VT is 12. I1 is 0.5. V3 is 2.5. V4 is 5.0. R3 is 10. Okay, before I go any further, I'm going to do the 2 out of 3 for this one. You always, when you see it, just do it. The more things you have, the easier the question becomes, right? So, and same thing, like just now, if you need to write it up at the top, V is I times R. If I want this column, I is V over R, and R is V over I. If you need it, write it out. Okay, so to get I is 2.5 divided by 10. So I get 0.25. Okay, and I can't do my RT because I don't have the value for all the R. So I'm going to move right on to the ohms, the Kirchhoff's law. So do your table faithfully. Always do it. The format is good. Remember how I said, do the VI, write the keyword. I want the loop, I want the parallel, I want the junction, and I want the series. Like, keep it the same. I would have it at my study note too, just so that I know these are all the ones that I have to write. Okay, draw my loop. I'm going to go to the top. Okay, so I went through T, 3, 2, and 1. So gain is VT, the battery. I went through load 3, 2, and 1. I did not go through V4, right? I didn't go through this one, okay? But V4 is parallel. What is V4 parallel to? V4 is parallel to these two, okay? Do you recognize that that is in parallel? I'm going to erase it because it's getting really messy. Okay, I'm going to leave back my loop. The loop is at the top. But what we do know is the parallel. These two together are parallel to this one. And what that means is V2 and 3 together are equals to V4. Junction. Junction is the split. Our junction is right here. Okay? And the junction has the current coming in this way and coming out this way. I have one thing split into 2. Are you okay with that? I only have I like this dot has one thing going in and 2 things coming out. What's the name that's going in? Okay, this is I what? Okay, if you're not sure, remember how I said take your finger, trace it back to the first thing you hit. The first thing I hit is the T, is the battery, so I say IT. So IT is the current that's coming in. And then I got split, okay? The first one, what's the first thing that I touch? The third, so I3. Bottom one, the first thing I hit is I4. Okay, things that are in series, hopefully you're okay with the series being, I don't know if you see it, but 2 and 3 are also in series with each other. These two, because they're in one line. Okay, so if they're in series, their current is the same. So I2 have to equals to I3. And then at the same time, what else is in series? I'm going to use orange. Okay, these two are also in series. Okay, when they're in series, their currents are the same. So I1 equals to IT. Okay, I think that's all the equation I could write. Sometimes you could have more than 4, depending on the situation, okay, or how complicated the circuit is. Okay, next thing I want you to do is inventory what you have. All right, so take a look. So from the chart, whatever you have, you check off your equation. And the key thing is you look for the equation that only has one unknown. And then you check, and then you solve for it. Okay, so let's do the V. I have V3, 4, and T. So 3, 4, and T. Okay, so I've checked out all the voltages. And current, I have I1 and I have I3. Okay, so those are all the ones that I have. Find equation that you have one thing you do not know yet. Okay, so there's actually quite a bit. Okay, if I do this one, do you see how I2 and I3 are the same? So I'm going to go to the chart. I2 and 3 are the same, so that means I can write that that's also 0.3. I2 and 3 are the same, so this is 0.25. So this is the one that I use. I'm going to change this. Okay, so to get the purple, like the light purple, I know I2 is the same as I3. Okay, and if I2 is known, I'm going to check it off as well. And then I'm going to go to the other thing that I could do. Do you see other equations that you can work on, right? So how about this one, right? This one, I1 is equals to IT. I1 equals to IT. So IT is 0.5 as well. I have IT. Oh, I'm going to check off IT. Look, I have my I4. So if I want to solve for my I4, IT is 0.5. I3 is 0.25. What is I4? So I subtract the 0.25 to the other side. I4 is also 0.25. Okay, and then I put I4 is 0.25. I know I4. Okay, that's looking good. I have all the currents already. Okay, next thing I would do, you can either work on the voltages or maybe take a look at the 2 out of 5 and see if we can solve a bit more. I'm going to do the 2 out of 5 and I'm going to figure these two out because I already have the voltage and the currents for them. So R is voltage divided by I. So to get number 4 is 5 divided by 0.25. So I get 20. And to get number 5, R5, I would go 12 divided by 0.5, which is 24. All right, got more current, got voltage. Okay, now let's look at the voltage. Okay, I don't have anything more, but I know I can use this one, right? Because I only have one thing that I don't know, so I'm going to start working on this. All right, so V2 I don't know, but I know V3 is 2.5 and V4 is 5. So V2 is 5 minus 2.5. So 2.5 volt. Okay, V2 is 2.5. Fill it in the chart. V2 is 2.5. Okay, then keep going. I now have 2.5 is this, so I can solve for my V1. So I'm going to bring my arrow down here just so you can see the full work. I know VT is 3 plus 2 plus 1. Vt is 12, V3 is 2.5, V2 is also 2.5, and then V1. To get V1 on its own, I'm going to have to bring these two guys over by subtracting. So 12 minus 2.5 minus 2.5 equals to V1. V1 is 7. So finally, finish it off by using the 2 out of 3 again. R is V divided by I. So V is 7 divided by 0.5, which is 14. And then to get the last one, 2.5 divided by 0.25, I have 10. Super big question. Remember, this is the most important chart, okay? Without that chart, you probably don't have enough equation to solve for the rest of it.